In last recording, I demonstrated two examples in question number 1, and then we're going to go in this recording a number of other questions. Now, this question number 2, this is even in your last chapter test. So just to try to see whether or not you can see different things and using the rule to express certain log in terms of other things. So now here we go. This log 3 is A, log 25 is B. Now expression for log 9/5. Now first of all, right away you can see this could be using the quotient rule to become log 9 subtract log 5. Now here log 9 and log 3, then you will think, okay, that is fine. I could know what log 9 is all about by A. Now log 25 here, we could change that into 2 log 5. And so that equals to B. So then therefore the log 5 equals to B over 2. So therefore log 9 is 2 log 3 and subtract log 5. Okay, well then here we go. Then 2 log 3 is 2A, log 5 is B over 2 minus B over 2. And then that is just the solution. All right. Oh, my nose is running. Okay, now this question is rather difficult. There are two things need to be located. First of all, you see, all the things given is log base 10. So log 3 equals x, log 5 and log 7. Now, all of a sudden, there's like 12.6. When I first saw this question, I thought, is this a typo? But then I thought, well, I need to try to see whether this is just a typo. It's absolutely cannot be done. Or as a matter of fact, it's just a difficult, interesting question. So I thought, okay, I'm going to factor this to see whether or not in this factor there's these log 5, log 7, log 3. So as soon as you factor that, you will see, yes, this is that I just factored 126. Then, of course, we realize this is a 2, then that is 63. And then there is a 3, and then there's a 21, and there's another 3, and there's a 7. It's like, interesting. You see, there is a 7, sure, log 7 there. The 3, sure, is here. The problem is there's a 2. There's no log 2 given, but they're given a log 5. I'm thinking, that's interesting. Well, then you see there's a log 2. So that means this log 2 could, there's a log base 2, but it could also be changed to log 2. Well, then the log 2, that could be 10 divided by 5. So let's just see how we can do this, all right? It's a bit tedious. The first thing I did was I changed this very naturally. This is third root, cube root. So that becomes this log base 2 to that, okay? And then this one, as I said, I don't like a decimal, so I'm going to get a whole number. When you get a whole number, that means that equals that log base 2, and that is 126 divided by 10. Now from here, I thought, okay, well, then that's what I mean. This is a common factor of a 2, so then that becomes 63 over 5. Okay, so this is starting to be a bit of promising here. So now this is log 63 over 5. However, don't forget, this is still log base 2. Well, then in this case, I'm going to change, and this is still a 1 over 3 at the top, at the beginning. And then I am going to change to base 10, okay? So that means the base 10, log base 10 to the 63 over 5 over, using base change rule, then that is over log base 10 of 2. Okay, so now log base 10 of 2 here, now we're saying that this is log 63 over 5, and this is log 10 over 5. You see, now we know that log 10 is just a 1. So from here, then you got log 63. Log 63 subtract log 5. And log 63 is this, 2 to the power of 3 to the power of 2 multiplied by 7. And then here you got log 5. There's subtract log 5. So from here, then you can every single thing expressed by log 3, log 5, and log 7. I just feel it's too tedious to do this one. Now hopefully you guys have the patience to gradually open this up by using the quotient rule. And don't forget, there's also in front, there is 1 over 3, and you should be perfectly fine. So this question, the matter factor is to think that this one, you can be thinking that is that, and the next one is this log 2. You can say, okay, well, the log 2 is not given, but the log 2 I can change to that. So this is 2 point of this question. Okay, so then let's see whether or not there's another question that I should do. I also now talk about the question number 3. Okay, so now question number 3, solve. All right, solve. Okay, so I picked up, this question number 3 solve. I think you guys are all good, so that should not be a problem. But so I like to do this question number 4. So let's just try question number 4. Let's just quickly try this one, okay? Now this one, the problem is that compared with our exponential equation before, the thing is that, you see, there's not the same base. There's nothing in the same base. You see this? There's nothing in the same base here. So in this case, that means if you change logs and then solve it, or it just means just change logs. But then you can solve it, because if you change it to log 10 base, and then you can use your calculator to get the number, right? So then what's going on here? So first of all, change them into log 10. So that means both sides I just consider is a log 10. So this is 3x equals to log 10, 5x minus 1. So in this case, that means 3x multiplied by log 2 equals to x minus 1 multiplied by log 5. So in this case, it also means move this to the bottom, move that to the bottom. So 3x divided by x minus 1 equals to log 5 over log 2. Okay, now some of you, when it gets to here, you might find, oh my gosh, what's going on here? Okay, well, cross multiply, so that means 3x log 2 equals to, this goes over there, just like that. So that means log 5 multiplied by x, subtract log 5. this kind of manipulation, when we did some other, like I remembered when we're trying to do the inverse equation, we did this kind of manipulation. So then what's going on here is that I'm going to move this to that side. I'm going to move this to the other side. So that means x log 5 subtract 3x log 2 equals to log 5. Okay, now pull the x out. See, this is how you isolate the x. So then pull the x out, then you got log 5 subtract 3 log 2 equals to log 5. And therefore x equals to log 5 over log 5 subtract 3 log 2. So this very important thing here that I hope all of you will develop this ability, and this is even for physics, is very important to be able to so-called isolate x by doing this kind of manipulation, and in the end your x equals to that. And here says in terms of log something, log 10, and then that's fine. But if it needs the number, you just punch into your calculator and then you got a number here. Okay? All right, so now let's see whether or not I should demonstrate another question. I discovered there was one question is interesting. So let's go to question number 7. The other questions I think that you should be able to try by yourself. It should not be too much a big deal. But I discovered this question that is very interesting, this one. Okay, so let's see what's going on here. Sorry, this recording seems to be so all over the place because my nose is running. Solve for x. Okay, so solve for x. All right, so solve for x, sure. What I did was, okay, well, I'm going to square both sides, right? So then when I square the left-hand side, that just becomes log x. And then the other side becomes log that, multiply again, that. Now note, what is this? This is 1 over 2 log x, right? So I thought, oh, that's so easy. Okay, so here we got a log on this side, log on this side. Now we got 1 over 2 log x to the power of 2. Okay, I thought, oh, this is so nice. Okay, so log x equals to 1 over 4. By the way, there's a couple of students to this day, when you have this one, you still do not square the 1 over 2. That's why you made a mistake on your test. Okay, so then this means to the power of 2 the log x. Oh, then I thought, okay, well then this one cancel with that one. So that means now log x equals to 4. Now log x equals to 4, x equals to 10 to the power of 4. That's my solution. And then I look at the answer key. The answer key says, well, there's also another solution called x equals to 1. And I was like, why on earth is coming to x equals to 1? I thought about leaving this question to all of you to think about, but I won't have a chance to talk to you. So I think that, okay, I just explain how I missed this another route. This happened when I just canceled log x. So because there is a possibility that log x equals to 0. If log x equals to 0, then yes, x equals to 1. So without thinking that possibility, I just canceled divided by log x. But if log x equal to 0, you cannot divide by log x. That's why I missed this one root. So then that also links to this question. This is a very, very interesting question. It's just once a while we think, gee, that's easy. Let's just divide it by log x. Did not realize when this is equals to 0, you cannot divide it. So you have to do another solving, okay? Do another solving is also, it's easy. So then you just use this as 1 over 4 log x squared. Now subtract log x, then that equals to 0. So then you factor out a log x here, and then you got 1 over 4 log x subtract 1, that equals to 0. So you see here, then you got either a log x equals to 0 or log x equals to 4. Because you did not divide this, therefore this solution remains.